Hello, and today's learning target is I can solve and graph a compound inequality. Let's look at filling in the first statement. And as you recall, this statement has been in many prior videos, so this shouldn't be too difficult to fill in. But remember, when multiplying or dividing by a negative, we must flip the inequality. So I'll fill in when multiplying or dividing by a negative. Flip the inequality. So let's take a look and solve and graph the following compound inequalities. Let's look at the first example here. So we see an or statement, okay, but we are still going to solve both of these inequalities separately. So with this first one, I'll go ahead and subtract 1 on both sides and get n is less than or equal to -4. And then when I solve this second inequality, I'll divide by -4. And when I divide by a negative, I have to flip the inequality symbol. So I'll get a greater than sign. And right here, this or statement is in the first part of the problem, so that actually gets written in our answer. So how we write our answer is we say n is less than or equal to 4, or n is greater than 2. So now when we graph that, I'll go ahead and it's -4, excuse me. I'll just count by 2's to make it easier and start with -4, -2, 0, 2, and 4. And then n is less than or equal to -4. Means I have a closed circle at -4, shading to the left. And n is greater than 2 as an open circle at 2, shading to the right. And so this would be my answer written out. N is less than or equal to -4, or n is greater than 2. And then here would be the graph to my that follows my solution set, which is right there. Okay, let's take a look at the second example. So this says x plus 8 is greater than or equal to 9, and x divided by 7 is less than or equal to 1. So we'll go ahead and solve both of these inequalities like we did the last example. And I'll subtract 8 from both sides and get x is greater than or equal to 1. And then over here with the second example, I'll to undo the division of 7, I'll multiply by 7 on both sides and get x is less than or equal to 7. And then we have and here in the middle of our statement. So I'm actually going to write my solution when I see an and statement with my variable in the middle, my smaller number on the left-hand side, my larger number on the right-hand side, and then we need the inequalities to essentially be facing the same way. So when I say x is greater than or equal to 1, that symbol will look like this, right? 1 is less than or equal to x, and then x is also less than or equal to 7. So your inequality symbol should be facing the same way as they are, and you can see if you write your solution set correctly. So this will actually be the final answer of how I'll write my answer here. So when it's an and statement, you'll put x in the middle, lower number on the left, higher number on the right. And then let's go ahead and graph this. So I'll go ahead and write 0, 1. I can probably fit all these numbers in here. Oops, something's on my stylus. And then I'll say x at 1, there's a filled in circle, and at 7, there's a filled in circle, and x is greater than or equal to 1, but also less than or equal to 7. So you should see an overlap of the two inequalities like we do here on our graph. So this would be the answer to the second example. Let's move on. Okay, now for this example, we have quite a bit going on, but let's go ahead and break this down and solve both of the inequalities, and then it is an or statement, so we should see a gap in our two solutions. So let's go ahead and solve this first one, and we'll add 8 to both sides. So -5b is less than or equal to -60. Divide by -5, and when I divide by a negative, I have to flip the inequality symbol. So I get b is greater than or equal to 12. Now if I solve the other inequality over here, I'll add 12 to both sides and get 11b is less than -100 plus 12 is -88. Divide by 11, so b is less than -8. So now I'm going to go ahead and graph these two inequalities, and that should say or in the middle. Whoops, there we go. And then I'll count by twos again, so negative 12, maybe I'll go by negative fours, or fours. Negative 8, negative 4, 0, 4, 8, 12, and that will be good. So I will put an b is greater than or equal to 12, open circle at 12, or filled in circle at 12, shaded to the right. And then for b is less than negative 8, an open circle shaded to the left. And again, there should be a gap, and there is a gap right there. So this is a correct or statement. So again, I'll circle my solution set, and then there is my final graph. All right, this next example says 36 is less than or equal to 11 minus 5x, which is less than or equal to 36. So this is really an and statement with one long, the two inequalities making one long inequality statement, compound inequality, of course. So let's go ahead and solve this. So I'm going to look at essentially almost two equal signs, but I have two inequalities. So what I do to the middle here, this middle area, I have to do to both sides of the inequality as well. So let's go ahead and let's isolate the variable x that's in the middle right here. And so what I would first do is I would subtract 11 from all three areas. And 36 minus 11 is 25. These cancel out, and I'm left with negative 5x. Fill in the inequality symbols, and 66 minus 11 is 55. Now we'll go ahead and isolate that variable x and divide by negative 5. And when I divide by a negative, what do I do with the inequality signs? I have to flip them all. So this both signs actually change and will point the same way still. And 25 divided by negative 5 is negative 5. 55 divided by negative 5 is negative 11. And if you look, this statement already has our variable written in the middle with, the numbers have to be flipped because negative 11 is less than negative 5. And again, it's proper to write my variable in the middle with the lower number on the left, higher number on the right. So we'll flip those around. And when I do that, I also have to flip the inequality symbols. So I get negative 11 is less than or equal to x, which is less than or equal to negative 5. And you can see the signs didn't change, right? I had to flip them because I flipped the order of the negative 5 and negative 11. So that also made the inequality symbols flip. So I'll put here negative 12. We'll do negative 11, negative 10, negative 9, 8, 7, 6, 5. There, I could fit them all in. So I'll have a closed circle at negative 11, closed circle at negative 5, and then x is greater than or equal to negative 11, so it goes this way, but also less than or equal to negative 5. And again, we should have an overlap with an and statement, and this was an and statement. It was actually one long inequality statement that also represents an and statement, not an or. So this would be the answer to this, this inequality. Let's move on. Okay, so again, I have a couple steps to solve within this inequality, but I do see it's an and statement. So let's go ahead and solve both of these inequalities. So I'll add 10 to both sides and get negative 2v is less than 16. Divide by negative 2, so I have to flip the inequality symbol and get v is greater than negative 8. And then over here, I have subtract 12. 6v is less than negative 18. Divide by 6, so v is less than negative 3. This is an and statement, so I'll put x in the middle, negative 8 on the left, negative 3 on the right, and I need v to be greater than negative 8, and v is less than negative 3. And again, if you wrote your and statement correctly, or your final solution set for your and statement, both inequality symbols should be facing the same way, which they are. So now I'll finish graphing this. And then I have an open circle at negative 8 and an open circle at negative 3. and then greater than -8, but less than -3, and there is an overlap there for that and statement. So we are done with that graph and that inequality. Let's move on to the next example. Okay. So we see we have an and statement, so let's go ahead and solve both inequalities. So I will first subtract 4a and get 8 is greater than 7a plus 15, and I'll subtract 15. 8 minus 15 is -7 is greater than 7a. Divide by 7, so -1 is greater than a. I'm going to flip that around and get a is less than -1. And now I'll go ahead and solve this next inequality over here. And I'll add the 14a and get 13 is less than or equal to 13 plus 11a, and subtract 13 and get 0 is less than or equal to 11a. Divide by 11. 0 divided by any number is 0, so 0 is less than a, but if I write that with my variable on the left-hand side, I get, and this is an or equal to symbol right there, so a is greater than or equal to 0. So if we think about it, and I kind of plot my graph, some of you maybe can catch this without even graphing. If I have a is less than -1, that's going to look like this, and a is greater than or equal to 0, like this. This is supposed to be an and statement, but we don't have any overlap. So if we have no overlap between the two inequality statements, then we do not have a solution. This is actually no solution because there is not any numbers that actually, I should write no solution because there is actually not any numbers that go into both of these inequality statements. So this is no solution here. So we just write no solution, and we would actually just have an empty graph as our answer. We wouldn't even fill it in. Thanks for listening. Have a great day. Bye-bye.